Okay, great then. By this video, I will explain extra information about chapter 10. Now, first of all, chapter 10 is that chapter that talks about moles, that there are a number of particles in a substance. Moles are important because we use them in order to make large numbers into small numbers. One of the best ways to use the moles, or the scientists who discovered the moles put the carbon-12 as a reference, and he found that in each representative particles we have 6.02 times 10 to the power 23 of atoms, molecules, ions, or whatever. So in order to convert between moles and these representative particles, we use the Avogadro's number. Example, if we say how many moles are there in 6.02 times 10 to the power 25 atoms of carbon. First of all, how to solve in all questions. I start with the quantity that's given. So 6.02 times 10 to the power 25. Then we add the multiply, then the conversion factor. The conversion factor that we have it here is the conversion factor between moles and atoms, which is Avogadro's number. What I want moles. So each one mole has 6.02 times 10 to the power 23 of any representative particle. When we divide, we will have 10 to the power 2, which is 100 moles. Okay? Then, in the lab, I couldn't understand moles. Moles are important when we make calculations because it's a unit for everything. In the lab, we understand mass. I can weight or give a weight for something or a mass for something. So the conversion factor between moles and mass is the molar mass. How can I use the molar mass? The molar mass has a unit of a gram per mole, so it depends. If the question wants the mass, I'll put the mass on the top. If the question wants the moles, I will put the moles down. It depends on the location. Let's take this example. What is the mass of 12 moles of carbon? I start by the quantity that's given in the question, which is the 12 moles. Then I use the molar mass because between moles and mass, the conversion factor is molar mass. The molar mass of carbon is 12. I want the mass, so I'll put the mass on the top, moles down, so the answer will be 144 grams. On the other hand, sometimes for some elements that they are gases, at certain conditions that they are 0 degrees centigrade or 273 Kelvin or 32 Fahrenheit, 180 and 101.3 kilopascal, these elements that they are like gases, they have, each mole of them has a certain volume, which is 22.4 liters. So I can use this conversion factor, which is a 22.4 liters per mole, to convert them. The example is, how many moles are there in 44.8 liters of neon at STP? I have to look at the question. The question should mention that it should be at STP and it should be a gas. Then I start by the quantity given, 44.8 liters, times the conversion factor. What I want moles. So I want moles on the top, liters on the bottom, then I get the value. If we have the opposite, we will do the opposite. Example, if I say, what is the volume of 4 moles of neon at STP? The same thing, I start by the quantity, so I'll say 4 moles. Then I multiply by the conversion factor. 1 mole is down, 2.4 liters on the top. So I multiply 4 times 22, which is approximately 88. Okay, then density. The density of the gases is important. We can calculate it at STP also by using two conversion factors together. We can use the molar mass and the volume. Sometimes the density is given, so I need to find out the molar mass by using the volume. Example, what is the density of hydrogen gas at STP? When I say hydrogen gas, it should be diatomic, so it has a molecular formula of H2. Now, I want the density, so I have the first conversion factor, which is the molar mass. The molar mass of hydrogen is 2 times 1, which is 2. Then I want to find the density. This one is a gram per mole. How to find the density? The density has a unit, gram per liter. So I should keep the gram on the top. So I'll say 2 gram per mole times, I have to get rid of mole and put liter instead. So I'll use this conversion factor. 1 mole over 22.4. So the answer will be 2 over 22.4 gram per liter. This is the density of the gas. Then, the molar mass of compounds, how can we find it? It is the summation of molar mass of individuals or each element. Example, methane, how to find the molar mass? Carbon is a 12, so 12 times 1, because I have only 1 carbon. Plus hydrogen is 1, 1 times 4, because I have 4 hydrogens. So 12 plus 4, which is 16. What's the unit? It's a gram per mole. Okay. Next, the percent composition. How can I find the percent composition? I have 2 ways. The first way, that the mass of the element and the mass of the compound are given. The second way, that I just give the formula of the compound. Let's see an example on the first one. That I have 80 grams of carbon dioxide has 2 grams of carbon. What is the percentage of carbon? So we just follow the formula. 2 grams of carbon over 8 times 100%. This one will be 1 over 4, which is a 25%. Okay? On the other hand, what is the percentage of carbon in CO2? Here, I didn't give a certain quantity. I want it in general. So I'll use the other one, the molar mass over the molar mass of the compound. The molar mass of carbon is 12. The molar mass of the compound is a 12 plus 16 times 2, which is 32. So it will be 12 over 44 times 100. You can calculate it. Okay, so you can find the percentage. Then, the empirical formula. How can I find the empirical formula? The empirical formula, it is the formula with the least numbers. How? They have to give me the composition. If the composition is not given, they should give me the masses. From the masses, or I can bring out the composition, or I can bring out the percentage. Now, how can I start? I convert the percentage into grams. So I'll say 70 grams of oxygen. Then I have to convert it into mole, which is the language that we use it in chemistry. So times 1 mole. How can I convert it? I have to use the molar mass. So over 16 grams. Then the other one is carbon. So I'll say 30 grams of carbon times 1 mole over 12 grams of carbon. Then I start calculate. Let me calculate them. So the first one, 70 divided by 16, it will be 4.375. The second one, 30 divided by 12, it is 2.5. Now, this is the mole of oxygen, and this is the mole of carbon. Then I'll divide by the least one. So 4.375 divided by 2.5. So the ratio of oxygen, it will be 4.375 divided by 2.5. It will be 1.75. The second one, the percentage of carbon, it is 2.5 divided by 2.5, which is 1. So approximately